All right, here let's look at some examples that are from the book in regards to this section. Now, you're going to expect most of these to involve the side-side angle, two sides and a non-included angle. And as we do that, let's take a look at what we're given here in exercise example number 1. Apologize, I'll call it example number 1, which is based on number 8 in the book. Now, I don't worry about drawing the angles exactly. All we need a picture for is reference. So here's angle A, here's angle B, and here's angle C. They're telling me C is 28, B is 23, and they're asking to determine the number of triangles possible with the given part. So notice the directions. They don't want us to find anything. They don't want us to necessarily solve the triangle. They just want us to know the number of triangles. And then they also give us angle B is 54 degrees. So with that being said, 54 degrees is, let me see if I've done that right, 54 degrees, 23 is opposite it, and 28 is opposite the C. Awesome. So how are we going to do this? No problem. You're going to look at this and say, holy cow, right? That's what you're going to say, holy cow, I know an angle and the side directly opposite it. This is the law of sines. Now, ideally, we want you to remember that this is the ambiguous case of the law of sines, right? This is the one where we're not going to be able to determine whether we have one or, well, this is one where we could have one or two that happen. So let's go through the process. I want you to see what happens. Sine of 54 degrees all over 23 needs to be equal to, and the right angle to get next is C, right? Because we know the side opposite it, 28. So we know what to do. We're going to take and multiply both sides by 28 because we're algebra masters, right? You wouldn't be taking this unless you loved math and loved algebra, right? You chose a major at least that loves math and loves algebra. Sine of 54. So I have 28 times the sine of 64 divided by 23, and that is equal to 0.98480, and it keeps going, sine C. Now, that's good. That means we have at least one solution because that is possible for sine C to be. You remember that sines lock between -1 and 1. So we have at least one triangle. Let's go take the sine inverse of that answer. As we take the sine inverse, so C is going to be equal to the sine inverse of that previous answer of 0.984890. And what comes out for C in my calculator is 80.02. So I'll just say 80 degrees. Now, we have to remember that sine is positive in both quadrants 1 and quadrant 2. So we found the first quadrant angle that could work. And so we would go from there. So there definitely is one where C is 80 degrees. A would be naturally then 180 minus 80 minus 54 and exists, right? 180 minus 80 minus 54 brings me into 46. So A is 46 degrees. So there's one triangle. Now, they didn't ask me to find that. But now we got to ask ourselves the question, could there have been, or could a quadrant 2 angle also fit in the triangle? That's a good question. Can a quadrant 2 angle also fit in the triangle? Let's find out. What would that quadrant 2 angle be? That quadrant 2 angle would be an 80-degree reference angle in quadrant 2. So remember, it was 80 degrees. It's much bigger than that. But 80 degrees back here. So 180 minus 80. So would a 100-degree angle work for C? And the answer is yes. Because remember what angle B was. Angle A is going to be 180 minus 100 minus 54. If that can equal a number, 180 minus 80 minus 54, 46 degrees, that's what A could be equal. Oops, not minus 54. I did that wrong. 180, I said minus 80, but I meant to put in minus 100. Sorry, it shouldn't have been the same thing as we got with the other one. 26 degrees. 26 degrees. Sorry for that hang up. So yes, there's a whole second one possible with a 100-degree angle for C a 26-degree angle, and then 180 minus 100 minus 26, and a 54-degree angle um, for angle B, which we already knew, right? So there's definitely another one in there. So two possible angles, so they're triangles. So the answer for this one is two triangles. So remember the process. The process was, well, let's give it a shot. Let's go find B. I'm sorry, we knew B to find C. So we find angle C. We recognize that angle C does exist because the sine of it's less than 1. And we find that inverse, and the inverse function is always going to give us the first quadrant one, and we get 80 degrees. Then we check to see if there's a second quadrant one. Sometimes the answer to that's going to be no. So let's take a look at example 2. Find the unknown angles in triangle ABC for each triangle that exists. So let's look at this one that's number 18. What they're telling us is, again, I'll just draw my standard ABC. This is 82.2 degrees. A is 10.9 and C is 7.62. So we're going to say to ourselves, this is definitely the law of sines. And sine of 82.2 degrees all over 7.62 needs to be equal to sine A all over 10.9, or sine A is equal to 10.9, just with simple algebraic movement, all over 7.62. So that's 10.9 times sine of 82.2 divided by 7.62. And the number that comes up is 1.4172, and it keeps going, is equal to sine A. So the wise student, the one that's learned something from the first stuff, will know that they're done. The one that's not so observant will it will take sine inverse of this number, and it will say it does not exist. Sine is blocked between 1 and negative 1. And so therefore, to have something come out as 1.4 through a sine is impossible. There is no triangle that can do this, right? And so no triangle exists that would have that. And so it's impossible to solve for the other angles because they don't exist. For this triangle to have those dimensions of 10.9 and 7.62, with the 7.62 being opposite the 82.2, would make it impossible for that sine for A to exist and for it to be a triangle. It's trying, but it can't. And so what's it like? It's like that short little leg that didn't connect in those pictures that you saw in the last video. In example 3, we have a triangle. Again, just drawing my standard one, never worrying about what it looks like because it's just for points of reference. A, B, C. And what do we have? C is 52.3 degrees. Little a is 32.5. And little c is 59.8. And what do they want us to do? They want us to solve the triangle. So if we're going to solve the triangle, we need to know little b. We need to know angle A. So in the end, I need to say what little b is, what angle A is, and what angle B is. No problem. How are we going to do this? We're going to look at the triangle and ask ourselves a question. Is a known angle opposite a known side? And the answer is yes. Sine of 52.3 degrees all over 59.8 needs to be equal to sine A over 32.5. And so again, we're going to get 32.5, just trying to take it slow for you. Sine of 52.3 degrees all over 59.8 is equal to sine A. If that number is less than 1, then we're going to be able to move forward. If it's greater than 1, we love it because we're done. There's no triangle. And it's less than 1. I'm getting a 0.43001279 is equal to sine A. Now I'm writing that down just for your benefit. What you know we're going to do is take the sine inverse of that answer. and we're going to come up with 25.46. So I'll say, since the other one was rounded out to the tenths, I'll say 25.5 degrees. Now the question is, could a second quadrant angle exist? So one triangle has A being 25.5, and we can sign that. Now we got to check that same question. Is there a quadrant 2 angle that would work? Well, let's see. The quadrant 2 angle would be a 25.5 degree reference angle in quadrant 2. So we'd be backed off 25.5 degrees. So it'd be 180 minus 25.5. And you can see how all your old work is coming in here. So everything's really about the investment that you made in the very beginning. 154.5 degrees. Now, is 154.5 degrees viable? And the answer is no. Let's watch it happen. Look what happens when you allow A to be 154.5. Remember, C is already 52.3. What happens if you add those up? What's 154.5 plus 52.3? You get 206.8. Well, that's a huge problem because those are just two angles in a triangle, and the triangle has to be less than 180. That second quadrant angle pushed it up above 180. Therefore, there's no second triangle, and so no. So you can see the difference. Here, when we looked for that second quadrant angle, it was 100 degrees. 100 degrees plus the 54 still left us underneath 180. Therefore, there was another angle that would work for A, 26. Here, when we tried it, the second quadrant angle 154 mixed with the already known C angle put us above 180. Therefore, no A would exist, and that's not a viable angle. So we now know that this is 25.5 degrees and the only one, so it's a one solution. And we do 180 minus 52.3 minus 25.5. And that tells us B is 102.2 degrees. So I said it, but I didn't write it. 180 degrees minus the original 52.3 degrees, which was angle C, minus angle A, which we found out to be 25.5. That's what gave me the 102.2. So the only thing left we need to do is find angle B. I apologize, side length B. Well, that's easy now that we know the other. I'm just going to give myself a little bit of room here. You can back that up if you need to see that explanation. Keep in mind there's worked examples in the text that are going right through all of these. And so what are we going to do? Well, why don't we say what we want, B over the sine of angle B that we found is equal to, and I always stick with what was originally given, the 59.8 all over the sine of C, which was 52.3. Right? And so how did I choose to put it in this form, to put my side lengths up top? Because I wanted a side length. Now I know B is simply 59.8 divided by sine of 52.3 times sine of 102.2. And that's just going to give me what my side length B is. So 59.8 divided by sine of 52.3 times the sine of 102.2. Be careful to close what the sine's operating on. And we get a nice 73.87. So maybe I would say 73.9. And there were no, there were units given, yards. I was going to say there were no units given, but there were. And so that's the only solution, right, that comes out. There was only one triangle that existed. And so we got a couple more examples, a little bit more. 1, 2, 3. I don't know if we'll need to do that last one. Okay, so if we look at this next one, this example 4 that's right here, it's going to be very, very similar. And so our job is to solve this triangle as well. So let's go through and do this one at least, and maybe we'll start to the next video after that. A is 51.20 degrees. BC, little a is 7208 centimeters. Little c is 7986. So again, we know an angle and the side opposite it. And so we're going to start there. Sine of 51.20 degrees all over 7208 needs to be equal to the sine of c all over 7986. And so 7986 times this sine of 51.20 degrees all over 7208 needs to be equal to sine c. So let's see if that's even possible. 7986 times sine of 51.2 degrees divided by 7208 is equal to 0.863456297 is equal to sine c. So c is going to exist. And what is that sine inverse? 59.7. 59.7. They went out to the hundredth, so I will too. 59.71 degrees. Now, what is 59.71 plus the original 51.20? Well, whatever that is, that's, well, apologize. I was going to check something that didn't need to be checked. So that's the first quadrant angle. So we definitely have one triangle that's going to work. So one of the triangles is going to, remember what we need to find, all the measures of the angles. So we would need to find the unknown angle C, the unknown angle B, and little b. That's what we need to find. And so one of those has 59.71 degrees. And then if I take 180 minus the 51.20 minus the 59.71, I'm going to get 69.09 degrees as the B angle. And then to get little b, no problem. Little b over sine of 69.09 needs to be equal to, I'll stick with the original, 7208 over sine of 51.20. And so let's find out what little b is. 7208 divided by sine of 51.2 times sine of 69.09. And when we do that, I get the number 8639.76. So 8639.8, and that was all in centimeters, right? And so if you told me 8640, no problem. You're not going to lose points for how you choose to round it. The question is there a second triangle? So what is 180 degrees minus 59.71? What is that quadrant 2 angle that would have the exact same sign? 180 minus 59.71 is this number, 120.29. Now what's 120.29 plus 51.2? So 120.29 plus 51.2 is putting us at 171.49, which means there's a second angle because that's not to 180 yet. So if we look up the makeup to 180, there is another angle. So angle C could also have been 120.29 degrees, which means angle B would be the makeup from 171.49 to 180, or more specifically 8.51 degrees, and that's going to give us a new little b. Little b over the sine of 8.51 needs to be equal to the 7208 over sine of 51.20, and we just go find that little b. So little b is equal to 7208 divided by sine of 51.2 times sine of 8.51. And that's going to give me a side length of 136 8.7 centimeters. So there's actually two triangles that would be present that could be formed off of those. And so they want them both when both can happen. This could feel a little bit overwhelming, but if we take a step back to realize what we do, and then I'll do a video with the others, really our steps are simply this. Number one, draw a picture. Okay, so what could that picture look like? That picture could look like this: 7, 6, 5. And then we would use the appropriate law. This one would be unlocked with the law of cosines. Now, why does the law of cosines have no ambiguous case? That's because cosine is negative in the second quadrant. There is no second quadrant angle that could come out. Everything's in the first quadrant. And so there's no question at all about what law of cosines gives you. It's only that first quadrant angle. What else could have happened when you drew that picture? When you draw that picture, sorry, let me get an eraser in here. When you draw that picture, you could have been given angle A is 25 degrees, angle B is 30 degrees, and you could be given the side in between them. Well, this is the law of sines, but not an ambiguous case. So this one right here would be the law of sines. Now, why am I saying it's the law of sines? Because you can absolutely get angle C. You know that 25 and 30 only get you to 55, so the makeup is C to 180, and then you would unlock everything. There's no second angle that C could be, just one solid angle. So whenever you're given two angles, no problem. What else could have happened? You could have been given, anytime you're given two angles, it wouldn't matter what side. So anytime it's two angles, it's a law of sines and it's a slam dunk. It's only the times that you're given two sides. And, well, how about a non-included angle? I'm sorry, yeah, the included angle. What if we were given side C and side B and that non-included angle? What's that going to be? This is also going to be the law of cosines. Right? There's no way you're going to figure out what little a is. There's no way you're going to figure out what B is or C is with just one angle. And so this is log cosines. Again, log cosines is never ambiguous. You just follow it through, just like you did in the previous time you're experiencing 7-2. So the only time you're going to have to worry is when you're picking the law of sines and you don't know all the angles right away. What does that look like? That looks like exactly what we've been dealing with. Two sides, little a, actually, let me put A there, A, B, C. I'll fix my problem. Little b, and if you were given angle A, if you knew this was 25 degrees, then this would be the law of sines, but it's ambiguous because you don't have a slam dunk for the other two. So there could be two triangles, and there could be none, or there could be one. That's what we're getting from this experience. So park that, and then I'll make another video about the last examples.